So good afternoon, everyone. My name is Carolina Mateaus. I'm the R&D Director for De Laval. And I'm going to follow Linda's presentation talking further in the processing of milk. So I'm not going to talk about milking itself, but milk quality when it comes to cleaning the surfaces and sanitizing the surfaces that are in touch with the milk. So at De Laval, we have a proposition that we can improve cleaning efficiency and have a positive impact on production, and at the same time save time, water, and energy when we do that. We want to do this by delivering a simplified cleaning routine without decreasing the efficacy of that cleaning. So just to review basics of cleaning, because this is my life, but it might not be everyone's life. So for cleaning, we have several components. The first one is water, and it removes most of the soil that is on the surface. So it prepares that surface for the chemical. The next component is time. So this includes the total cleaning time, the time for prepping the surface, the time for warming up the water that you're going to be using for cleaning, the time for assembly and disassembly of the equipment. Then we have the chemicals, and so we use different types of chemicals when we do cleaning, and I'm going to go into specifics of those, but it includes the concentration of the chemical, the type of chemical that we're using, and that depends on the type of soil that we're cleaning and how that soil has been adherent to the surface, whether it was a cold processing surface or if it was a hot processing surface where some of the soil could have been burned onto the surface. Then the temperature that we use for cleaning, so we know that just like when you wash your dishes, warmer water tends to remove the soil better, but you need to be careful with that too because you don't want to burn soils as you're cleaning onto that surface. And the final, any mechanical action, and that is either the flow of the liquid through the tubing when we're doing cleaning place, which is cleaning through the pipelines of the processing facility, or actual mechanical action when you are scrubbing the surfaces. So the cleaning process, I'm going to mostly talk about CAP, which is cleaning place. And what this means is that most facilities that have flowable foods, so for example, milk, what they do is that you have all these pipelines that are connected and they're flowing the milk. So from the clusters where you're milking the animal all the way down to the cooling tank, the milk is flowing through pipes. When you clean those pipelines, instead of unplugging them all and scrubbing them all by hand, what you do is that you connect them to chemical and you run the chemical through it. So that is called cleaning place. And it's either a 4-step cycle or a 6-step cycle. So on the 4-step cycle, and this is normally used on cold processing surfaces, we have a pre-rinse, then we have a chloralkaline wash, then we have a post-rinse, and we follow that with a sanitizer. The chloralkaline wash takes care of protein and fat residues that are left on the surface. And then the acid sanitizer step takes care of 2 things. It removes, if there's enough acid, it will remove any mineral deposits that are left on the surface. And then, of course, the sanitizer part will take care of reducing the number of microorganisms that are left on the surface. We can also have a 6-step cycle that is normally used on equipment that gets really dirty or equipment that is exposed to extreme conditions. For example, any heat during processing, so HTSDs and pasteurizers. So we have a pre-rinse, we have an alkaline wash, then we have a post-rinse, and we follow that with an acid rinse. Sometimes we do another post-rinse and we chase that with a sanitizer. We may skip that post-rinse if the sanitizer is acidic in nature. We may just inject it at the end of that acid wash. So it's just a typical example of what we would do, depending on the size of the lines, of course. But we may have a pre-rinse that is fairly short, and we start increasing then the temperature of the water at that point. Then we have the detergent wash, which is the alkaline or chloralkaline. This is more extensive, and it goes at higher temperatures. We follow that with a post-rinse. We try to keep this at high temperatures so that the temperature of the equipment is not decreased during the rinse. Then we have an acid rinse. It's more or less the same time as the detergent wash, again at high temperatures. We have a final rinse, and at this point, we really don't care about hitting that water. We start cooling down the equipment. That will help us also save time for when we start processing, because we're not gonna wanna start processing on a hot surface. And then we do the sanitizing step, which just gets done at room temperature. There is no need to heat up the sanitizer. So D-Laval produces two types of products. We call some of them conventional products and the others enhanced products. The majority of the presentation is going to be talking about our enhanced technology. So for the conventional products, these are competitively priced products. They meet the basic market needs. We are talking here about detergents. We're talking about descalers, common sanitizers. We have from very, very simple formulations, just a caustic solution, to a little bit more robust formulations that may have additives in them, chelators and other things that help lift the soils. But we have, our value is on both cleaning performance and on the price. We also, however, have enhanced products, and what our enhanced products do is that they're more robust and highly formulated products. And so what we're looking to do with them is to either eliminate steps in the cleaning process by combining the cleaning, the alkaline cleaning with the acid wash, or by combining the sanitizing with the acid rinse, or we're looking to be able to clean at lower temperatures so you don't waste time heating up the equipment and letting the equipment cool down. So these are just examples. This is the same table that I just showed you of more or less what the steps are for standard cleaning. If we go with one of our products, is called One-Step Alkali. What we're doing with this product is that we are eliminating your acid rinse. So a mostly alkaline product is able to both remove organic soils and remove some inorganic soils present. We may go to our One-Step Acid, which is another example of a product where we skip the alkaline step, and so we go from a pre-rinse to this detergent step that is acidic in nature, and we follow that with a sanitizer step. Or we may have situations where what we're doing is that we're decreasing the temperature of cleaning, and with this product, we're actually, if we follow that product with an acid sanitizer, we're able to do the organic soil removal with that product at a lower temperature and chase that with an acid sanitizer that takes care of both of the mineral deposits and the sanitizing of the surface. So I talked a little bit about this already. Of course, the features for us with these enhanced products, we want to clean, descale, or sanitize in fewer steps. We want to be able to use lower water temperature and use less water. But for the customer, what we're really talking here is lowering costs of cleaning, lowering cost of energy, lowering cost of water, lowering cost of labor because they don't need as many people, or they can move their people from one cleaning area to another one because the area is liberated faster. They can start production faster. So let's talk first about Cool CAP. So as I mentioned before, it's a product that works at reduced temperature. It is a chloralkali product. We have very good cleaning and rinsing from this product. It helps us lift, break, and remove organic and protein soils. And it also works well in hard water, so it reduces a lot of the mineral deposits. These are just examples of different products that we have as far as the alkalinity. So you see the alkalinity is a little bit lower, but we're able to compensate of that alkalinity with the amount of chlorine that we have in the products. It's very effective at removing proteins. A little bit on the chemistry. So we have, of course, the chlorine component that is going to take denatured proteins and is going to help us lift them up. And we have then the mineral component. We have a lot of chelators and other components in the product that are going to help us lift the minerals from the surface. And just to give you an example, so this is a small commercial dairy operation here in the US. Because it's a small commercial dairy, what we did is that we increased the soil level in the holding tank by holding that milk for 24 hours longer than it was supposed to be held. So we wanted to create a stronger layer of soil. We looked at raw milk tankers and receiving lines, row lines and storage tanks, and also the cream lines and storage tanks. So you notice all these are cold processing surfaces. We started with a dose of 1 ounce per gallon, or we looked at 1 ounce per gallon as our dose that we wanted to achieve in a cleaning temperature of 145 degrees Fahrenheit, and we ran the trial for 28 weeks. So this is what we were doing before, the chloralkaline detergent versus cool CAP, which are the light lines. And we see two graphs here, the energy consumption and the energy cost for this company. We see a tremendous decrease in energy consumption. It is about 2/3 less when we use cool CAP. Similar situation with the cost of energy, and this was a very small facility. So we were able to provide them with this product, about a 60% reduction in energy cost and about $16,000 a year in reductions in savings, including the change in cost in chemicals, so that's included in the calculation. So for a small facility, it had a very big impact, and for our customers, it's very important, it's very easy for them to translate then to the size of facility that they have and envision the savings that they could have. So where do we use cool CAP? Of course, on flowable foods is the best way to use it. We use it on fluid dairy. We use it on manufactured dairy, so yogurt, cheese, ice cream. And some powder products it's worked well. It's worked very well for us on liquid egg facilities. Any sauces and dressings and juices, we have a lot of those facilities. Maybe I should say here that DeLaval not only works on dairy farms and dairy processing, but we also work on other food processing areas. And yes, tomato and carrot juice is something that we work with. We used it mostly on cold food processing surfaces. We've used it with some success on brewing companies. So the objectives, or what we've been able to achieve with it, is certainly reduce cleaning times for cold process equipment. It is mostly important for us when we're able to find a piece of equipment that is a rate limiting step in our processing, and if we're able to reduce then the cleaning time by not needing to heat up that equipment and then allow it to cool down, it really has helped production in the facility. Okay, the next product that I want to talk about is also an alkaline product. It is called Premium Plus Alkali. Again, it's a high alkalinity content.